Thermodynamics short notes: heat Q, energy exchange due to the temperature difference. Q is equal to C del T, Q is equal to N Cm del T, Q is equal to M S del T. C heat capacity, Cm is molar heat capacity, S is equal to a specific heat capacity, M is equal to amount of substance. General value of the Cv and Cp for an ideal gas can be taken as the follow. Work: reversible, irreversible. Work: reversible. Negative integration b1 to b2 p external dot dv w irreversible is equal to negative p external b2 minus b1. Sign conventions: internal energy E and U. Every system having the same quantity of the matter is associated with a definite amount of energy called internal energy. U is equal to U kinetics plus U potentials plus U electronic plus U nuclear plus and so on. U is a state function and is an extensive property. Del U is equal to U final minus U initial. For a given closed system, U is equal to F in bracket T V. Del U is equal to del U upon del T V dt plus in bracket del U upon del V T del V. First law of thermodynamics, law of the conservation of energy. Del U is equal to Q plus W. Enthalpy: chemical reactions are generally carried out at the constant pressure, atmospheric pressure. So it has been found useful to define a new state functions in enthalpy as H is equal to U plus PV. Del H is equal to del U plus del PV at the constant pressure. Del H is equal to del U plus P del V. Combining with the first law, del H is equal to QP. Hence, the transfer of heat at the constant volume brings about a change in the internal energy of the system, whereas that at constant pressure brings about a change in the enthalpy of the system. For a given closed system, H is equal to F Pt, dH is equal to del H upon del T P del T plus del H upon del P T del P. P del V is equal to N del Ng RT, where del Ng is equal to number of moles of the gaseous products, number of moles of the gaseous reactant. Del H is equal to del U plus del Ng RT. P is equal to QV plus del Ng RT, where del Ng greater than 0, then the del H is greater than del U, where del Ng is smaller than 0, then the del H is smaller than del U. When del Ng is equal to 0, then del H is equal to del U. For reactions involving only solids and liquids, or when a reaction is carried in the closed vessels, del V is equal to 0, thus del H is equal to del U. Extensive and intensive properties. Extensive property is the property whose the value depends on the quantity or size of matter present in the system. For example, mass, volume, internal energy, enthalpy, heat capacity. Intensive property are those properties which do not depend on the quantity or size of matter present in the system. For example, temperature, density, pressure, molar volume, molar heat capacity. Relationship between del H and del U. The difference between del H and del U becomes significant only when the gases are involved, insignificant in solid and liquids. Del H is equal to del U plus del PV. If the substance is not undergoing chemical reactions or the phase change, del H is equal to del U plus N R del T. In case of chemical reactions, del H is equal to del U plus del Ng RT.